video is going to show you how to combine energy, conservation of energy, with the work done by non-conservative forces. A 75 human cannonball is shot by a force of 9,500 newtons across a distance of 7 meters. He starts from rest at the bottom of the barrel. An average resistive force of 303 newtons acts against him across the first 10 meters. During this time, he shot up 9 meters above the starting point. How fast is he traveling at this point? So he shot out of the cannon that's 7 meters long, and then there's a resistive force working against him for 10 meters. So in other words, after he comes out of the barrel for additional 3 meters. And at this point, he's 9 meters above his starting height. In other words, it's going to look something like this. Here's the cannon. It's going to have a 9,500 newton force pushing him out of the cannon, and that's going to act for the length of the barrel, basically at 7 meters. Now there's going to be a small resistive force of 303 newtons acting against him, but that force is going to act for 10 meters, so in other words, beyond the end of the barrel. And when he gets to that spot on the right, he's going to end up being 9 meters above the ground. The question is, how fast is he moving at this point? So what I'm going to do is I'm going to use my conservation of energy, summing up all the energies at 2 different locations and comparing them, and then combining that with the work done by each non-conservative force. And I have 2 non-conservative forces. The one that's pushing him out, and one that's not pushing him out, the resistive force. Remember, the only conservative forces that we're considering are those due to gravity and springs. So I'll start by summing up the energy at 2 locations. I'm going to pick the bottom of the barrel because I know the height and the speed, and the top of the barrel at 9 meters, again, because I know the height and I'm looking for the speed, so the question actually gave me that clue. So I'll sum up the energy at the bottom, plus the work done by the cannon, and these are all the steps that I'm looking for when I'm grading the work. Now, the cannon adds energy to what he had at the bottom. That's why I'm adding it in the equation. The resistive force removes energy from the bottom. So he starts off with some energy at the bottom, then I add what the cannon added, that gives him more energy, but then the resistive force removed energy. So you can see where I added the force of the cannon and the distance he moves, they move in the same direction going up the barrel. The 10 meters and the 303 meters, they move in opposite directions, and that's why that's a negative work. Okay, and that's all equal to the sum of all the energy at the bottom. So these are the steps I'm looking for that you start off with, indicating your energies and your works. Then for the sum of the energies, I'll have the kinetic energy and the potential energy to gravity. Then I'll have the plus of the work of the cannon minus the work of the drag, and all that's equal to, well, another kinetic and another potential energy. But now I got to figure out which of these energies I can remove. So I'm going to ask my same questions as I've been doing before. So what I'm going to do is I'm going to look at the bottom location. I'm going to ask, at the bottom, is he moving at this location? And he's not. He's at rest. So that kinetic energy is going to go away. Then at the bottom, is he above the other location? And the answer is no. So every time I answer no, I get rid of the energy. So I'm going to do it again. Now, the work of the cannon and the work of the drag, I'm going to leave those alone and look at the top of the motion. That's when it's 9 meters above the ground. And the question is he moving at this location? And I think he is. I'm hoping he is. And the next question is it above the other location's height? And it is. It's 9 meters up. So since I answered yes to both those, I'll keep those energies. Next step. I'll take a look at the force and the distance of the cannon minus the force and distance of the drag force. Notice I put little subscripts just to kind of remind me it's 7 meters and 10 meters, so I don't think they're the same. And that's going to equal the kinetic energy at the top and the potential energy due to gravity. I'll throw in all my numbers. Notice that the distances for the forces aren't the same because they don't happen that way. One acts for 7 meters, one acts for 10 meters, and that's okay. So the only unknown I have is the speed at the end. So I'll solve for that, and I get 38.9 meters per second.